Hey guys, welcome. Let me give you a reminder. If you are in second period, remember that you will have your review on Monday afternoon. I'm going to try to give you a little update here. So, if you are in my second period, Math 3, your review time on here is Monday afternoon at 12:15. So from 12:15 to 3 o'clock, and you can meet in my room. Um, if you do have questions about some things in Math 3, like some things that you're doing that are not related to the exam, that won't be on the review, then you could come earlier in the day from 8 to 10:45, and you could go through some things there if you need extra help finishing up assignments and getting grades in and things like that. But our review for the exam is 12:15 to 3 o'clock on Monday. Third period. If you're in third period Math 3, our review, again, you'll come to my room, but our review will be 8 a.m. to 10:45 on Tuesday. Again, 8 a.m. to 10:45 on Tuesday. And again, second or third period, um, during the fourth period time, the 12:15 to 3 o'clock, you are able to come if you need any extra help or getting through the course, so that you can make sure you get through the course on Canvas. So those are options for next week that I just wanted to make you aware of, and so that you had that information. Okay. So the next thing that we're going to do today is jump into section 3, which is hypothesis testing. And the hypothesis testing here in section 3 is just kind of a brief overview of some things you'll see in statistics. If you move to AP Statistics next, which I would hope a lot of you in second period, that's your next math class that you're going to take. So consider this situation. This unopened bag of chips is half empty. And the question is, I wonder if it really contains 28.3 grams like the package says on the front. This type of informal question or observation is the beginning of a lot of investigations. So the question may be, do Spud potato chips contain an average of 28.3 grams of chips per bag? Suppose you conduct that investigation into Spud potato chips and you find that the mean weight of the chips in your sample is actually 25 grams rather than 28.3. Do you think that a difference of 3.3 grams between the actual weight, which is 25, and the advertised weight, 28.3, is large enough that it needs to be reported? If so, how do you report this information and to who? So, a couple ways you would do that is one, maybe try contacting the company by sending them an email. You may file a consumer complaint, meaning that like you feel like as a consumer you're getting ripped off. And then you could also file a complaint with the Better Business Bureau, the BBB, if you've heard of that. And those are for complaints when businesses are not doing what they say they're supposed to. In some situations, a researchers are even more formal, and they state what we call hypotheses. In this case, there is a null hypothesis. They call that HO, and that generally states that there's no difference and nothing going on. Null is dull, is what they call it. And then there is an alternative hypothesis, which states that something is different, something is incorrect, or something has changed. So in this potato chip example, the null hypothesis would be that the true mean weight, the true average weight of the chips is 28.3 grams. Okay. The alternate hypothesis would be that the true mean weight of the chips is less than 28.3 grams, which means like they're giving us less than what they're supposed to. So that would mean something has changed. They're giving us less chips than what they really should be. To be concise, researchers often use symbols in place of words, and so Greek letters are usually used when referring to populations. The population is the entire group being studied, kind of where we'll get our sample from. English letters are used for samples. So, for example, when you discuss the mean, if we're talking about the population, we're going to use what's called mu, or that U symbol. And if we're talking about the sample, we're going to use what's called the X bar. So the hypotheses for a study can be stated in words or symbols. When using symbols, you need to identify what they represent. So you always want to use mu when you're talking about the mean, because our hypotheses are going to be what we're saying may be true about the entire population. So our null hypothesis is that the mean equals, this should be an equals, the mean equals 28.3 grams, and the alternate hypothesis is that the mean is less than 28.3 grams. Notice these are the same numbers. It's either equal to or less than on here. The mean is the true mean weight of potato chips for Spud's potato chips in one bag, right? So what would you do next to determine which of these hypotheses is true? You would conduct a more thorough and accurate sample. So instead of just getting like one bag of chips, you would go through and sample many different randomly selected bags of chips, and then you would find the weight of that entire sample. And then you would determine what's called a p-value. And a p-value tells you the probability of the null hypothesis being true. If that value is really low, then we'll say that this alternate hypothesis is true. If that value is high, that means there's a higher probability that this is true. Then we may be able to say that it actually is true that there's 28.3. So for questions 5 through 9, you want to practice writing hypotheses. You can write them in words and then convert them to symbols and sketch an outline that might help. So in number 5, a local pizza shop advertises an average delivery time of 20 minutes or less, but it does not offer a guarantee such as free pizza. The national manager, Sue Lin, wonders if they're really fulfilling the claim. So she thinks it may be more than 20 minutes. So the null hypothesis, HO, is that the average delivery time is 20 minutes or less. And the alternate hypothesis, what we call HA, is that it is actually taking more than 20 minutes. Let's look at number 6. James believes his mother's, in number 6, James believes his mother's houseplants would grow taller if she watered them with rainwater instead of tap water. So the null hypothesis, this should be equals. Null is always equal to. So if they put a less than, it really needs to be an equal to. So the null hypothesis is that the rainwater is equal to the tap water. And that's why you see an R and a T. And then the alternate hypothesis is that they would actually grow taller if she watered them with rainwater, so that the rainwater is greater than the tap water. That would be the alternate hypothesis. Okay. Number 7, according to the U.S. Census, 2005 U.S. Census Bureau, they say that at least 10.2% of registered births in the United States were to teenage mothers. So that is the null hypothesis, that the proportion equals 10.2%. However, a sociologist believes that this percentage has increased. So he thinks that it is now greater than 10.2%. So the P stands for the proportion, and that is the percentage of births registered to teen mothers in the United States. Let's look at number 8. In number 8, this again will be an equal to for the null hypothesis. Always an equal to for the null. According to the Federal Housing Finance Bureau, the mean price, or the average price, of a single-family home in 2005 was $299,800. A real estate broker believes that because of a recent downturn in home sales, that the mean price has decreased since then. So he believes that it's now less than $299,800. And remember, the mean stands for the current price of a single family home. Right? So the mean is the current price of a single family home. Number 9, lastly, Justin spun a penny from 1985 8 times and got tails, 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 tails. He believes the penny might be defective and the probability of landing on tails is greater than 50%. So that's what he thinks. But obviously, the null hypothesis is that the probability that it lands on tails is 50% because it should land on tails half the time and it should land on heads half the time. So our null hypothesis is that the proportion of times it lands on tails is 50%, and our alternate hypothesis is that the coin is wrong, it's defective, and that the proportion of times it actually lands on tails is greater than 50%. So those are just setting up null and alternate hypotheses here. For today, your work is just going to be to analyze some experiments that have already been done and to just explain what the difference in them are. So I'm going to give you some problems on IXL to just analyze some experiments. They should be easy. You're just going to have to tell what the difference is between the two. You'll be subtracting those and finding the difference using the information that's given in the problem. So if you'll head there, that'll be your work for today. And we've got one section left. That will be tomorrow. And then don't forget about the review sessions next week to prepare us for the exam. All right. Have a great day.